How's it going, everyone? Welcome, Javier Gonzalez here. And today I was going to look, continue to look at the chapter 3, which is Get Started book from the series of book of You Don't Know JS Yet, written by Kyle Simpson, a software engineer that has previously worked at several companies, and he has now more than 20 years in the field. In my case, because when I get into the computer science, and actually I couldn't finish that degree, in hugely because I like is the technical aspect that I find that's very interesting, appealing. It feels like playing here, but I do not like is the social aspect of this, right? But in understanding the thing that I don't like in the social aspect is mainly because the these ideas that live in the academy, that they have now particular individual and how they look like and how they supposed to act. And I do understand that that's great for that particular individual, but in my case it was not. And this is just put a philosophical aspect here very quickly. That's not for me. And this is when, in any field that you are decide what you want to do and how you want to do that. Because the thing, it matters more. It matters more what you do and how you do that, rather than how hard you work on it. So, because this hard work, it means that what is the destination? What is the end goal? What is the true of the hard work? It's just doing the hard work for the sake of doing hard work. And this is also something that a lot of in my family actually promotes. There is nothing wrong with that. But the thing here is that is effective, that is real, that is practical, that is tangible, that produce outcomes, that is rock solid, and most of the time is like just ideas, right? And that's why I decide to actually keep track myself of uh, recording this series of videos, to say, hey, you know what? I actually don't know JavaScript, not as supposed to, especially because I pick this language as just as a toy language, and when things don't go according to my thinking, which has happened to a lot of JavaScript developers, uh, so I blame the tools for doing the way, for working the way they do, right? And this is pretty silly. It's pretty much like when you broke your motorcycle or your fridge or your laptops, is blaming that somebody else for that, right? Especially if you now especially if you are going to do this, if you are devoting yourself, nobody else tells you to do that. But if you're devoting yourself to do a specific stuff, whether it's in any career, lawyers, uh, medical physicians, software engineering, so you have this law, medicine, engineering, uh, and social software engineering, right? And tech in these areas. There is also another areas as well. And the idea is to now understand what is the truth of all of this. And this is why I'm dedicating, as I mentioned before, not only this series of videos to actually explore about the ECMAScript, to understand this source of truth. So it's like now this Ptolemaic movement, or uh, the Copernican movement, where it say, hey, no, things are not what you think are, things are not what you should think they are, things are what they are. So this Copernican movement happens in my life is the reason why actually I'm dedicating, with the help, of course, of a mentor. But the mentoring in itself is not telling me, hey, this is what you have to do. It's like, look at this and there and that. No, 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 no. It actually helped me to open up the door, all right, or at least to show me the door. Here's the door. Here's the knob. It is up to you to decide if you want to go there. And then I decide to, because I want to ease my pain with the language. So anytime that I define a statement or an expression, I know what the French toast is that, okay? And also, because as we create and as we develop now more complex applications, it's very, very well important to understand the intrinsic nature of the language, right? Or in this case, this tool that you're working. So you can have now a better chance to not only make money, which is important, don't get me wrong, but also is to understand is not only the technical aspect, but also what you are trying to build. Whatever is you're working for any company, what are they trying to build, and what is the underlying truth about that, right? And that will now open up your mind as a subject master of that topic, and then you're starting to have more interesting challenge, and you have now is this understanding of what things are and know what things are supposed to. So because in this chapter here, we or Kyle Simpson actually describing that if you have read the chapter 1 and chapter 2, right? Just to make a quick recap of that. So in chapter 1, we went through understanding is what is JavaScript, why the name comes from, who makes this, who now oversees this technical specification, which is this DC39, who owns that legal trademark, which is Oracle, what this DC39 group or this technical commit group actually does, how they do the things that it does, what are their goal, right, which is avoid to break the web, and despite that this thing is made of several faults that works in different areas in the web related industry, browser makers, device like Samsung, so on and so forth, they don't know is the reality of the web because it's massive. It's something that it is a collective thing that sometimes even the technical group, which is this smart folks that works and dedicate time to actually understand and to promote certain features and make the web continue to work as it is, so don't break the web. There were some cases in the community that happen. So for example, Smooshgate, which one of them, it's a tragic comedy event that happens, and how now some JavaScript implementators decide to not go into or not implement certain features in the from the spec due to legacy reasons and to the reality of the web, right? And there is a particularly appends that you can find there. So also we look at how now the web guarantee this backward compatibility that unlike HTML or CSS, they just say forward compatibility, right? So with using polyfills is a way of how can we define is or how can we provide support for browsers that don't have those particular features, right? A good example is the finally in the promise objects, all right? And I would like to go into this just to show here a little bit that not to mention that, no, it's just to show you here is, let me see if I can show you without this exactly, please load this. Nope. Okay, but okay. But here is just to show you here is briefly is what we're gonna talk in the chapter 2, right? But in chapter 1 we also mentioned that what are the uh, conventions or approach to solve things based on a particular problem. And the problem is that if your problem is about cooperation or coordinations across different nodes, right? So object programming is so far the best way to do that. Whereas if your problem is more about computation to calculations, right? So functional programming is a more fit approach, and also it's the procedure, right? So because now in JavaScript, in order to understand how these things work, we need to look at this overview of how the JavaScript engine works. If this is an interpreter or a compiled language, the TLDR is that this is a compiled language because the phase that is describing here inserting operations when it comes to detect now errors, which is known as semantics, semantic syntax. So a good example here is when you look at the function's definition, right? Static semantic, sorry. So this is static semantic, which is evaluating from early errors, okay? It's something that now is it's not in essence, if in essence, if in if not in essence, in essence, if not in practice, make now this a compiled language. And then we look now at the concern about the speed of the language with ASM.js, which was a good precedence to show that hey, we can actually run is a JavaScript code, all right, that like this, we can run now JavaScript code, which is a subset of JavaScript that now provides some hints to the engines and allows to run is, for example, games in the browser. So I do want to know is a particular example here, right? It was in 2011, 2014, ECMAScript and AS, the role in the modern web. Let me see if the demo.
And that's what this talk is about.
Show here, right? Let me see the demo here. They show you here. But this is
32.
section. But I do want to know is the example here. The example is ASM.js example, right? Or a live example. If there is a engage development. The ASM specification is considered deprecated. Developers may look to WebAssembly as an alternative to ASM for running high performance code in the browser. So I just want to see if they actually now if there were a particular example of that, examples. Live example. So game live examples, right? Game of life, no. Unreal Engine 3 in Firefox, exactly. Okay, Game Informer. Engineering team at Mozilla and Epic for exactly an Epic pour Unreal Engine 3 to the web in 4 days. God damn, using ECMAScript and ASM, right? So this is actually to show that the language in itself is exactly compiled to JavaScript. The language in itself, indeed, is fast enough, right, to run this. again, this is a subset of um, a subset of sometimes the early games in the shop, it performance like native application indeed. I remember the bug original review saying that the web is more fun for trolling than for playing on or coding games inside a browser. As time goes, even further from hardware. It is expensive hardware-wise if games are downloaded in real time. Streaming or demand, they don't see the attraction until everyone on gigabit on the internet or something similar. I do think so. Will went over. But in any case, the point is that they pour this game, right? They pour is the Unreal 3 engine to the web. Alright, so now by compiling it to this subset of JavaScript, right? So to show you this kind of stuff. And because the concern was that JavaScript is not a fast, it's not a language that is not a fast language. So this showed that it was possible, and then years later, WebAssembly now takes this successor. It is the successful it is the spiritual successor of the this subset of JavaScript, right? But it say, hey, let's gonna things go a little bit further by skip the parsing phase, and then now have this intermediate representation that look like an assembly code, where we can now is compile that into this was environment. It can be run that particular code. So this goes beyond the scope of today's video, but I do think that is quite important to at least have a now sense of what has happened in the community, and also that things that happen in the community is a strict mode is to say, hey, in this strict mode, we are going to now put some guidelines of how to do things the best for the JavaScript engines, so it has a better chance of optimizing and running your code. So developers must stick to this in order to do that. So in this strict mode, we have things like how things are gonna behave in functions. For example, the functions definitions. For example, is that without strict mode, you can define is now a eval or the arguments, and then override the built-in functions that the language has. But in other words, with the strict mode, you can do that, and there are other certain constraints, certain behavior that change now. So another good example is that, hey, how now did this value, which is something we're going to explore in today's video, how did this value actually now, so what is the value of this value when you are in a function definition? And then on the chapter 2, all right, we discussed about is the serving JavaScript, serving or knowledge in JavaScript, how JavaScript see each program and how each program is a file, all right? And the only way that they cooperate on their act as a single program is if they are sharing is the state, whether it's globally or if one of those files actually is sharing this public API and other files now are consuming, which is also true in EX6, this way of organizing our code that say, hey, when do you want to import certain files, all right? This particularly linking process or the co-organization actually is the one that makes JavaScript programs or files make or act as a single program, do this interoperability that happen. So um, that's great. That's actually open up your mind, especially of how now the JavaScript engine see all of this, according to Kyle Simpson as well. And when it comes to describe a program, so what a program is, which is a series of steps that we can define, and this is using now some values that we can represent in our programs, and what values are, which is the most basic information in our programs, that because this value is used by the programs to manage, it is a state, okay, states that we want to show to the users, or that we want to represent internally. So for example, like a series of character as a string, it actually follows a specific guides or rules, which is the Unicode, similar to the numbers, which is also it follow is the IEEE 7054 spec, right, that describes how it's going to be represented. And because we have now limitations in how much we can store in memory, this is why we have some issues known as the accurate issues, or in other words, the 0.1 plus 0.2, while in the F, this actually gives us is that 0.30004, right? Also is booleans, you have true and false, okay? We also have symbols to actually represent internal data that we don't want to even expose to developers, all right? Big N, which is somewhat recently introduced to that, so we can represent now numbers, longer numbers, and also is the kind of emptiness, such as undefined and null, and why we prefer to go with undefined rather than null, because when you want to determine that value, okay, it gives you that is now an object, right? And also objects is another type of values. And talking about values and determining what a value is in a language, all of the things that I mentioned before, as well as the objects, all right, which is this key map value, pretty much like a spreadsheet table when you have the identifier as a one, and then this second column that you can specify any type of values, whether it is all of the primitive, or arrays, or objects, or even functions. And I hit the brake here a little bit because to me that was revealing when I truly understand this fancy word that say, hey, first, functions are first-class citizens, okay? That a lot of people actually talk and express and yada yada and mention that. But it means that functions now are seen as functions now can be used as value, which means that the way how can we represent value in JavaScript is whether it's literals, the value in itself, or we can hold that inside of a container known as a variable. And how in variable we have is, well, this different syntax form that has inherent behaviors, whether it's var, let, and cons, which is more restricted each one of them, okay? So var is per globally or per functions, let is block scope, but you can redeclare that, whereas con is a more constraint and say, hey, it is only for per block. You can redeclare or redefine it, but you can mutate the value. And this concept of mutations, assign, and passing values are something that is relevant in the language, because when we now defining is that other places where we can store values are functions in the language as parameters or as a name functions, which is the other way of how you can define is variables here. This particular mechanism is something that I'm not well aware of, and I'm going to explain in later chapters. But the other place where a variable is defined is also in a try catch. And when we look now at a functions and what a function is in the language, how it behaves, which is whether it's a procedure or a functional programming, right? When that happens, if this is a pure functional programming which set a strict set of rules that must abide, which now give you is some of this benefit from the functional programming, or if you define that as a procedure that it can now is um, uh, have several line of code, several statements that can be either run once or multiple times. You may pass now inputs, one or multiple inputs, and it can return is one or multiple outputs, right? So this way of passing values or assigning values in the context of JavaScript, because in other programming language, the way how you can assign values to a variable or pass values to a function is by saying, by being explicit about it. In JavaScript, we don't. In JavaScript, we are now have to, whatever the value that you use, whether it's a primitive or an object. So primitive are their values are assigned or passed as copies, all right? Whereas with objects, their value are passed as reference. And there is now an historical reasons about that, because if you are now in the 90s, your constraints in terms of memory is huge, all right? So of course you want is to somewhat to make the languages memory efficient. So this is just me playing devil advocates with Brendan H. That say, hey, you know what? Yes, for any of these primitive values, we unfortunately have to copy that. We're gonna create space in memory for all of that. But for objects, we just only have one of them here, and any time that you now get that value and assign that to a variable or pass to, we would like to prefer to pass as a reference. And talking about a reference, and talking about is the other features of the language, is the way of how now functions, declarations, and function expressions are. So functions definition, again, this is something that I'm gonna explore that later better in other in other chapters. But I do find that this understanding is the core of the things that we're going to build, for example, in React Native and other languages or in other products here. So that's great, that's good. Um, with that, all right, now that we now that I look at the function definition and the function declaration, and when the association of those binding happens is, in the case of function definition, is at parse time, whereas now at the creation time, which is something that I'm going to look at that, in the function expressions, that assignment happening is when that line of code, or when JavaScript engines look at that particular line of code and execute that, right? So this is part of the concept that we're gonna explore, like hosting. Also, we look at the comparison in the language, which is the equality and the type conversions. Whereas in equality here, the way how we compare the same type if they have the same identity. So for example, you can represent now is here is 42 in different ways, and they all now represent is the same. So for example, you can have, hey, this is now is 42 the same as XX 2A, it's a true, and you say, what the fuck? This is the representation on hexadecimal, all right? This is the representation of in binary, right? And this is what it means, the identity, that no matter what, this value, it's itself. But when it comes to now compare that objects, for example, since the comparison is not per value, it's per the identity, it say, hey, if this now live in the same position as this, it's like you say in the numerical expression here, is to say, hey, if this 42, right, live in the same position as this another representation of the 42, and it say, yeah, it does. So and when it comes to compare now different types using is a double equal, so what is the algorithm is doing behind the scenes, right? So for example, you can say this is true, this is false, but if you do this, now you get this idea. But it turns out that this particular algorithm, which is a loosely equality, has now an inner, particularly well-defined set of steps to go with, right? So for example, if you're going to compare is different if you're going to compare different different types, all right, it's going to pass through this series of steps. Hey, if one of them is null or undefined, this is null, right? I don't care, bro. I don't care, right? If one of them is null or undefined, this is false. Sorry, if one of them is null or undefined, this is true, right? However, if one of them is now a string and the other is a number, then cohere that string into a number. And when it coheres this string into a number by saying is this, all right, this is now have a representation of a number like 0, and that's when you have this as true. And the other is that, hey, if you are for some reason, right, if one of them is now a string and the other is a Boolean value, all right, I want you to now convert that Boolean value into a numeric. I want to cohere that Boolean value into a numeric representation, which is, it turns now into 0, and then it's going to evaluate is the next one iteration to say, hey, if one of them is now a number and the other is a string, it say, all right, now let's going to cohere that string value into a number, which result in this, right? However, if one of them is now a primitive and the other is an object, try to cohere that object here, or try to cohere that object into a primitive. And when you do this, by default, the primitive is coheres into a number. So this is because the algorithm works in that way. It's going to provide now a hint, and if this hint is not provided, therefore it's going to assume that this is undefined. Therefore, the behavior is to cohere that into a primitive. So if you cohere now this into a number, what will be the expected output to this? Well, this is not a valid representation of a number, which is name. All right. And the other thing is quite funny because for object it says that, but for array, this is a 0, bro. you know. So you can do pretty this, and it will tell you, hey, this is true, right? So the algorithm actually follow is a very systematic, well-known way of works, way of doing things. So this is just to describe is now what it's doing, and also there is some more fancy stuff here. For example, like this, when you say uh, things like this, and why this actually tells you true, and again, is say if one of them, I'm going to first evaluate this expression, and it say, hey, I'm going to now coerce that. This is the same as you say boolean, right? This is the same as you say this. Um, uh, Not only to coerce that, but to negate that. Hence it is. This is what it does this. So this is going to coerce that into now a Boolean value, which say, hey, the Boolean value, I have a very well defined list of falsy values that empty array is not false. It is true. So once it coheres that into this, all right, it say now this is actually a false value, all right. So now this becomes is false, all right. And when you have now a Boolean value, it say, hey, let me now coerce this Boolean value into a number, right? This one. So if you know what is a Boolean, what is the Boolean value in a number, is now 0, and then it say, hey, if now one of them is a number and the other is an object, let me now is coerce this into a primitive. And if you don't pass any hints, by default I'm going to coerce this into a number. When you coerce it into a number, it gives you now 0 and therefore is 0. So despite that this tricky stuff that can do things here, right? And then you can get fancy of that to say, hey, what about this? And is this actually coercing into a Boolean value, which is now a false value? It's true value, and actually is pretty much the same as this, right? So you can get fancy as much as you want here. But in any case, that's the entire reason of all of this. So then we explore of the nature, right? POC app. All right, and this is just to describe is the comparison and coercion, both of them, and when it comes and what happened when it coerces those values, and what happened when it when it compare those values, which is known as referential equality, right? And also is that how the code is organized in a way that we can now, as a developers, make sense of what we're doing, and also for other developers and so on and so forth. So, but the thing is that as we do this kind of stuff, right? There are several way of how can we are organize our code. We have is the common one, which is models, where you have now uh, functions as models. All right, you define as a function, and then you define is inside of that all of these different private variables or data along that, and then the methods, and then you expose some of the things that you want to, right? The public API. So this model as a function, way organizing things with immediately invoked function expression actually works well for a long time. The other approach is now is the more modern approach with EX6, would say, hey, let's going to now define, let's going to say that each file is a model, all right? So we can import other files here, or we can now export is data and functionality so others can consume that, okay? And the way to do that is by using is the import and the export keywords. And you have now particularly syntax form to actually now import those data, that data from data and functionality from other models, and the same when it comes to export that. And the other is now class, which is the way of how traditionally organize our code around these objects, or around this a specific type, or this custom type of data structures that contains data and it is functionality that operates on that data. So this class, which is can be seen as a value, unlike the function in JavaScript and the EX6, they needs to be instantiated. You need to create that. That's what you have now is the new keyword function to execute that. But it's actually quite similar when you now look at how you can define now values in how you can put functions values in objects, which is pretty kind of similar of now how class actually works. And in fact, class actually is leveraging is the way how now objects is organized. This is just a syntactic sugar to actually look the code more like an object programming. But behind the scenes is now using is the composition between the object and functions as values here, right? That to me was wide opening, absolutely. And then now here in the digging into the roots of JavaScript, well, is to say, hey, let's make now a deep dive into into some of the low-level features that JavaScript provides to get now a sense of the field of JavaScript and to understand for sure most of those that are relevant for us as a JavaScript developers. So we can now understand is get a feel of how it ebbs and flows, right? So first is to understand the iteration, why we actually care about iteration, and because there are several companies with a ton of developers that are working on this language, and they all suffer in the face. Most of the time, they suffering is the same problems, which is how can we now is deal with consuming data one at a time, all right, in a way that is easy to understand and easy to replicate that, because the way or the particular patterns that we defined to consume data in order to process that, which is what a program most of the time does, is like, hey, let me take now all of this data, process that, to take now just to make decisions on that data. Okay. Now, in this, the way of you do that algorithm or the pattern that you use must be something that is quite easy to understand and to grasp on, because it will add some additional complexity, unnecessary complexity to the language. So this is why now they're having a particular standard, part of this design patterns, all right? Whether it is the creational or the structural or the behavioral, where now behavior here you have is the iteration, which is described the problem of what we have all of these different collections, all of these different ways to walk through, all right, and we need to find a consistent way to go to each one of those places, to consult to all one of these nodes in the data structure. So this is the problem that they have. So they say, hey, you know what? It makes sense to say, good, now let us here is to have this particular pattern, which is going to describe is now how can we consume is this data, and the way to do that is by describing now an iterator, which is this data structure that have a reference to the underlying data source, and expose now methods so we as a consumer can now call the next methods, which is a function that is going to give us the data as a value and as a boolean known as done. So if we are not done, we will continue to call that method until it is done. All right, and we can create now multiple instances of this iterator to actually consume this underlying data sources. So these data sources here, which is now this particular standard way to consume that, in EX6 we have now certain syntax that allows to consume that, whether it's using is the for of, all right, or the spread operator, or the spread or the rest operator, right? Where now the spread and the rest operator the rest operator is now convert all of the arguments that you're receiving into now a collection, into an array like. So this way of consuming those iterations is something that we were talking about here, right? When now that must have, that collection that we want to iterate must have implement is that iterator protocol. And how does it check that? Well, if we take a look now at the for of, which is something we're gonna do here, right? On the this is on the function in classes, statements and declaration, exactly. Statement and declarations. Why doesn't open up? This website is French toast. I French toast. I fucking hate this. Oh my god! You know what? It's not working. It's like what the? Oh, it's okay. What in the French toast? Okay, there you go. Okay. So here we got all of these statements and declarations, right? So statement is something that we have quite described over the course of years, over the course of videos. But a statement is, it can be is a block statement, it can be a variable statement, it can also be an if statement, it can be an empty statement, it can be an expression statement, okay? And this expression statement is look ahead if there are any of this to evaluate this expression statement, and the runtime semantic is evaluation. It's a let express ref be evaluation of the expression, and then return the value of this. You know, this is what an expression statement refers here into the language. It say, hey, I'm going to evaluate this, and I'm going to get a value. So I'm going to evaluate this expression if this is a valid expression, all right? And then I want to is now get a value out of this. So expressions here give you is a value, and I say give you and don't produce because this is what at the end of the day what is doing behind the scenes. So get the value of this. So here we got this expression in statements, all right? It cannot be any of this, anything on non-line termination here, function class, and it can be now an expressions. So expressions can be is an assignment expression, and this in the assignment expression we have now the conditional expression, which is the and or, and also bitwise or the short circuit expressions. This short circuit expression is whether it is the and or the collisions expression, all right, which is using is now this double here that is say, hey, if the value on the left is null, I'm going to take it on the value on the right, all right. If the value of the right is now present, good, now I'm gonna take that. So here you can see what it's doing here. So if the value is either null or undefined or null, then return is this, right? Get the value of the right. If it's not, return is the left value. So this is pretty much what it's doing. And this is known as short circuit expressions, okay? This is the short circuit expressions, logical or collision expression, which I do find that is great. In order to understand that, so short circuit expression can be logical, logical. Oh my God! Please. So logical or and exactly and or. All right. as well as bitwise operation. All right, logical OR, logical AND, in bit or wise expression, which I don't quite get this bitwise OR operation. I do find this is more like evaluating this bitwise SOR operation, evaluate string or numeric binary expression here, right? But yeah, this is to actually go into this low-level bits. We don't want to go down into that. But again, this is the short circuit expression, whether it's a logical and or expression and coalition expression. Okay, part of the assignment expressions. In an assignment expression, it's interesting that they call that, but again, just to put a label on that. So you have is the assignment expression, the conditional expression, which is short circuit expressions, logical and so logical or and or coalition, all right, as well as the ternary operator. Okay, it's another one. We also have is arrow function GIL expressions. So GIL expressions are assignment expressions, arrow functions, async arrow functions, and left-hand side expressions, like we usually normally know. So any of these left hand and right hand side expressions here, you know, followed by the and or and coalition as well. So this is what assignments represent here and then expressions. Okay, so you can have not only is one of these assignment expressions, but also is followed by another assignment expression. This is why this kind of stuff is a valid. For example, if you say now an assignment expression, this is why things like this, say our number one, we may say magic number, right? Magic number 41, and you can say is or magic number 2, and say 42, and this is actually a valid expression. You can also do that for let. Okay, magic number 3, magic number 4, and so on and so forth. Right? You can also have now is several of these expressions, which is that's quite interesting. So you can have an arrow function that say, hey, let me return is I'm an arrow function, you know. I'm an arrow function. I'm an arrow function, and you can also have another expression here and say, hey, I want to evaluate now if empty value, all right, and I want to evaluate if this expression null and empty value, right, and say, hey, it's a Boolean, right, and it say, hey, oh, of course, because it wasn't expected. That's right, an expected token. And they do this, right? This is quite interesting because is evaluating is the last one in here. Despite that you're passing is several of these functions, several of these expressions, is gonna give you is the last one, right? Because of this. So arrow functions as well as this, but at the end of the day, it's going to evaluate is let me say if I can. It's going to evaluate all of them. It's going to evaluate all of them, all of this sequence of expressions here. But in this case, it's going to give you is, again, this is not a true JavaScript implementation of the spec. It's just a friendly JavaScript. All right. So I do find that this is quite revealing in terms to understand what an expression is when we talk about what an expression. And an expression is either one of these. It can be, as I mentioned, is an assignment expression, a conditional expression, a yield expression, an arrow function, an arrow async function, as well as these assignment expressions or left-hand assignment expressions, right? Followed by, in the condition, you have now the short circuit conditions. You have the short circuit conditions. Yes, just recapping here. Short circuit conditions. Yes, short circuit conditions. Oh my God. Short circuit conditions and short circuit conditions. Okay. So short circuit conditions, like the and or, as well as the coalition. All right. And the ampersand and the conditional operators, which is using the ternary. And you got all of this. This is now an expression. This is an expressions. Okay? And look ahead for if you have now this. An expression statement cannot start with left curly bracket because that might make it ambiguous with a block. And an expression statement cannot start with a function or class keyword because that will make it as ambiguous with functions declarations, a generator declarations, and a class declarations. An expression statement cannot start with async function because that will make it ambiguous with async functions declarations and generator. And an expression statement cannot start with the two token sequence let here because that will make it ambiguous with lexical declaration whose first lexical binding was an array binding pattern. So there are some stuff that you cannot do here, right? So this is all about talking about the expressions, okay? That when you are now using and consuming iterators here, we went through say, hey, the iterator that we want to consume, for some reason, implement that, all right? Is that underlying data structure, implement that iterator, have this particular protocol when it comes to use a special syntax to consume that? For example, with the for of loop, which is exactly what I want to look at this. The for of loop, language statement and declaration, yes, must be here. But this most known as the iteration statement, like loop. So you have now an iteration statement is do while and for statement, and for in of a statement, which is quite new, right? The for in and for of and for await, all right? It also performs some early errors. It's a structuring, it's interesting, it's a structuring. But as we look at this, the for in and the for of, okay? So the for of and the for in, as we look at the for in, for example, this, this is a semantic early errors, all right? But what about expression, static semantic, and runtime semantics? For declaration binding initialization, for declaration binding instantiation, and for in of loop evaluation. Okay. And for in of loop of evaluation. let be this an expression or an assignment expression here, okay? Yes, this must be now an expression. In other words, this syntax form must produce is a value, all right? Whether it's in or off, okay? Whether it's in or off. It's going to say for in of head of evaluation, for in head of evaluation with expression enumerate or iterate, right? If this is using in with expression enumerate, if this using is now in, or an assignment, okay? In is for expression and off is for assignment expressions. So is this expression here is now producing is a value, all right, in or off. If this expression now producing is a value here with off, and that value, for example, here, let's take a look at this. Let key result be for in of head of evaluation, assignment expression in iterate, return for in of body evaluation, statement key return as iterate assignment label here. So let key result be for in evaluation of assignment expression and iterate, where here you have is what is doing behind the scenes. Okay, the asterisk operation for in head of evaluation takes arguments uninitialized bound names, a list of strings. Uninitialized bound names, a list of strings, expression, an expression parse node, or an assignment expression parse node, an iteration kind, enumerate, iterate, or async iterate. Look at this. So they're going to pass is now a particularly label here, iteration kind, and return either a normal completion containing an iterator record, or an abrupt completion. It performed the following step when called. Let the old env be the running execution context lexical environment. So it's like creating that, assigning that the uninitialized bounds is not empty, and then assert to this has no duplicate entry. Let the new environment be the new declarative environment for each string name or of uninitialized bound names. Do perform create mutable binding new dot and create mutable binding name and false, and set the so you can mutate that. Set the running execution context like environment to new env. Let expression ref be completion evaluation of expression. Okay. Left the expression ref be the completion of the evaluation of this. Set the running execution context. Interesting. Set the running execution context. Lexical environments to all environments. So in other words, it's creating now an execution context. Holy fuck. So force creating now a running execution context and the lexical environment to all environment, and make the variables to all environment. Let express value be get value of the express value, which is the expression that you want to receive, okay? And then if the iteration kind is enumerate, then if expression value is either null or undefined, return completion record of type break and value empty and target empty. So let the objects be the to object expression value. So it's gonna coerce that into an object, all right? And it's going to evaluate if that object that is receiving from the expression, from the expression that is passing here, from the expression that is passing here, for in of head evaluation, for the expression that is passing here, let key result be for in of head evaluation. I do think is this for in off. Yeah, we are evaluating if the iteration is iterate or enumerate. Okay, so if you're receiving now an enumerate, okay, if the iteration kind is enumerate, which is something that I don't know who defines that, it's part of the algorithm here. So if you pass now an expression which produces now a value, it's going to ask that question. It's going to say, hey, the iteration kind is enumerate, then the expression value is either undefined or null, okay? Then return the completion track of this, which a break, empty, and there you got it. Let the object, if it's not, let me now coerce that expression values into an object, and now let me enumerate all the object property and actually verify if that contain is the iterator next method. Get me that value here. And if it is, now you're going to return the iterator record here, which is the iterator next methods and next methods here. Is done is false. Else, sorry, if the iteration kind is either iterate or async iterate, if iteration kind is async iteration, let iterator kind be async, else be iterator kinds be sync, and return get iterator. And this get iterator is going to now evaluate exactly, and then now this get iterator, it say, hey, is this value that you're passing here is either async or not? I am going to now look at that value here from the express value and the iterator kind, and I want to look at that and see if that particular object contains now, or that particular value contains now is the symbol iterator. If it is, good. If it's not, French toast that. You know what I mean? French toast that. So, but all of this is interesting because it's creating now a execution context. So it's creating a new execution context here. And return the iterator record, which is this. And once it returns this iterator record here, all right, which contains this object, which is the iterator, the next method, and the done. This is something that you are not going to see then. And once it returns that, exactly, is that object contains not the iterator here. Enumerate object property and enumerate object properties. The iterator throw and return methods are null and never invoked. So in other words, this is just to explore about the for of loop, And I don't want to dive too much into this because there is other stuff that I want to explore. Uh, but this is the way of how you can now consume is uh, a value that has an iterator implementation via it is symbols, right? Where if it is now is going to call that here, it's actually telling you, right? It's actually going to call that to get that iterator and call the method next here, right? So let the next method get v, all right? And then it's gonna return that value here to this. Or in other words, it's just to verify that it has an iterator as it is, right? But it turns out that anytime that you are creating now a for, is creating now an execution context with the lexical environment, something that we're gonna see that later. But this is not how you can consume iterators by evaluating that value or that expression here, all right? So you can also do something like this. You can say things like, hey, this is a for if, but let's see for some reason, right? That is creating now a function here. And then you say it's generate 10 values. Say 10 values. Or you say is users, right? You have now a function that return is the users, right? You say async users, right? You say async users, right? So in this, for some reason, after an X amount of time, it's going to now return you that. So you can say function async. Just for the sake of the example, right? Let's get into this. Yeah, let's get into this. Async function here, right? So what I can do is to say after an X amount of time. All right. Oops. So after an X amount of time, all right, set timeout will going to return now an ID, all right, that that by the time that 1 second has already passed, or say 2 seconds has already passed, all right, I want to now is return is this, say user 1, no, and user 2. I am being quite manual here, and I know, right, just for the sake of the example, right, user 3, right, and there you got it, right? So the 2 second I want to is return is now the ID, but this is going to return is the ID, all right? So how can I actually is return is this value, all right? Well, I can now wrap this into a promise that represent now is like eventual completion of a value here, and say, hey, I want to create a new promise here, right? That by default you're going to receive now is the response and the reject, and this function here, right? So when you evaluate this, let me actually make it much more clear here. So because I'm passing you now a callback, a set of instructions here, okay? Yeah, let's make it this way. I want you to say, hey, when this is done, all right, when now the value is done, I want you to now is call the response object and now pass this value as it is, right? So this is to say, hey, it is interesting because we are also creating now a closure here, okay, by saying is something like this, right? But in other words, we can do something like this and say, hey, by the time that you now finish to evaluate that, all right, which will give you now an ID. So when that time is passed, so what it's doing here is, so you are going to schedule this, you're going to schedule this particularly function, all right? And you're going to schedule it by passing that to the event loop, and the event loop has now several queues. One of them is to process is a promise, the other is callback functions, and so on and so forth. So here it's going to put this into a promise, all right? And once that into the promise queue, known as micro task, and once that time is done, all right, which is, hey, I'm now going to schedule. So first we are scheduling this here as a promise. Effectively, we're telling to the environment, not the JavaScript, the platform here, the browser, to say, hey, I want you to schedule this promise into one of these queues that you have, the micro task queue. Good. So by the time that you execute that, all right, you're going to evaluate what you have inside of that, which means is, hey, I have now this set of instructions. I have this callback that say, hey, I'm going to also schedule is now this operation, this function, okay, this set of instructions, but in this case, instead of the micro task, I'm going to schedule that to the task queue, which has a lower priority on the promise, okay? And when that time is done, which is something that is handled by the web API, by the browser, I want you to now is pass these functions to the event loop. I want you to now pass these functions through the event loop and put that on the call stack so it can be evaluated. And then now it's going to say, hey, good, I want you to evaluate this, all right? And by the time that now the promise already have a value, okay, the promise will resolve here into this value that you're receiving, so you can now have access to this value here by the time that you call here, known as the async user, right? So there is actually no, because here is going to evaluate expressions, you can say is await, in my case, wait for this, and then now do that, right? And after 2 seconds, you get all of these values, right? The iterator value is this one, and so on and so forth. So, but the thing here is there's a lot of mechanism stuff that happens behind the scenes. Yeah, it's time to stand up. All right. Yeah. So based on this, okay. So it is safe to say, based on the following code, that when the async user, exactly, so when the async user function is called, here is what is happening. First, a new execution context is created. Okay. The return keyword. And that's interesting because I want to know what the return keyword actually do. The return statement, bro. Here, return statement. It say, hey, I'm going to now say this. No line terminator here and expressions. A return statement causes a function to cease execution. And in most cases, return a value to the caller. If expression is omitted, a return value is undefined. Exactly. If expression is omitted, a return value is undefined. So by default, all functions return undefined values. Otherwise, the return value is the value of expression. A return statement may not actually return a value to the caller depending on the surrounding context. For example, in a try block, a return statement completion record may be replaced with another completion record during evaluation of the finally block. Okay. Runtime semantic evaluation. It say, hey, return the return completions undefined if there is no expression, return completion. Okay. So you're gonna return you a record. Let's say, hey, this is the type, which is return value, and the target empty. It returns now. It takes an ECMAScript language value and returns a return completion, and it performs the following step when called. Completion record. In completion record, specification types is used to explain the runtime propagation of values and control flow, such as the behavior of a statement, break, continue, return, and throw, that perform non-local transfer or control. Exactly, because they are transfer control. Completion record have the fields defined in table like this. So whether it's a normal, break, continue, return, throw, abrupt, a normal completion. Callable objects that are defined in these specifications only return a number completion or throw completion. Okay. But in any case, this is the completion record specification, right? That is used to explain the runtime propagations of values and control flow. Okay. And values and control flow, such as the behavior of a statement, break, continue, return, and throw. Okay. That perform non-local transfer of control. But this is the key stuff here. This return keyword, all right, is it is used to explain the propagation of values in control flow, in control flows that perform non-local transfer of control. So that's exactly what happened. You're transferring its control then to the caller. So that's when when we go back here, that when the async user function is called, here's what happened. A new execution context is created. The return keyword evaluate the expression here, which is a new keyword. All right. It's a if you return something, it's going to evaluate this expression and get that value from the expression. If get generator kind is async, this is if you return an expression. Okay. So it's going to evaluate the expression and get the value. If the get generator kind, which is in this case is async, set expressions to await express value. Otherwise, return completion here. Okay. If get generator kind is async, get the context be the running execution context. Get generation context does not have generator component, return non-generator. And let generator be the generator component, get generator. And this get generator kind, the abstract operation get generator for control abstract operations takes no arguments and return non-generator, sync or async. It performs the following step when called. Get the generate, okay, be the running execution. Be the running execution, okay? And if the generator context does not have generator component, return no generators. So it is this running execution context has now some values here that I can access to. The running execution context, state component of all execution contexts. So whether it's code evaluation state, functions, realm, and the script or model. Additional state components for ECMAScript code execution context. Okay, so you have now is components of the ECMAScript, state components of all execution contexts, and the state components. So you have the co-evaluation, which line you are, exactly any state need to perform, suspend or resume evaluation of code with this execution context. You have the function, if this execution context is evaluating the code of a function object, then the value of this component is that the function object. And then the function object here. If this execution context, the realm from which associated code access ECMAScript, you have the realm record. Okay, so when an execution context is created like this, all right? So when an execution context is created, an execution context is a specification device that is used to track the runtime evaluation of code. Okay, so this execution context can be known as the frame. So execution contexts are like the frames, like the frame putting on top of the call stack. Okay. Yeah, that's a good way of thinking about it. Execution contexts are indeed like frames that get pushed onto the pop from the call stack. Interesting. Okay. So is this execution context, all right, which is this device to use to track the runtime evaluation of the code by ECMAScript implementation. At any point in time, there is at most one execution context per agent, and the agent is, what would be the agent? An agent comprised in a set of ECMAScript execution contexts, an execution context stack, a running execution, an agent record, and an execution thread. Except for the execution thread that constitutes an agent, belong exclusively to that agent. So what would be the agent here? So an agent in JavaScript is the JavaScript thread, or is the JavaScript process. Not exactly. The relationship between aging and JavaScript process is more nuanced than directing one-on-one mapping. And aging is more like an unit of execution isolation. Oh, so this is, if this is a unit of execution, if this is a thread. It's a broad concept that just a JavaScript threads. Uh, okay, an aging isolation execution environment that includes a worker agent, a shared array buffer scenario. Think of this way: threads, who is doing the work? An agent is what the complete isolation JavaScript world they are working in. So an agent is like, what is it? Um, what similarities we have, exactly, I know, similarities we have with other languages like Java or C++. Is a JavaScript in broad concept that just the JavaScript thread. Okay, so it add more like an execution environment. It contains its own heap, call stack, and event loop. Really? It doesn't have the event loop? An aging execution thread execute algorithm steps on the execution context independently on other agents, except that an execution thread may be used as an execution thread by multiple agents. Provide none of the agents sharing the thread have agent record, whose can block file is true. So, and this is agent record fields. An agent signifier is a globally unique opaque value to identify a agent. Opaque. So JavaScript agent is more like an isolated execution environment, and the main thread is just one agent. The primary one handles DOM UI most of the code, similarly with other languages. So Java, both have the call stack per threads agents, both have heap memory management, and both can run different Java thread shares memory by default and needs synchronization. JavaScript engines are isolated by default, share via message passing. So this is why these agents in JavaScript, C++ threads share the same memory space, and JavaScript agent has separate heaps, which makes them like a process, bro. Exactly. So JavaScript agents model is more like having separate process that communicate via message, while Java and C++ threads are more like having multiple workers in the same shared workspace. So in other words, an agent is like a process. So an agent in JavaScript is a process. Is a process in the OS. Okay. So JavaScript agents and OS process then compare with other languages. JavaScript agent is not exactly the same as an OS process, though they share some similarities. In practice, JavaScript engine often corresponds to a web worker, but then JavaScript runtime might implement multiple agents with single OS. So in other words, Jesus. So an agent is a process. Is a process. So an agent is like a process in the OS where the OS is the JavaScript engine. Each agent has its own isolated memory space. Agent can communicate via a message like IPC, and the JavaScript engine schedule and manage multiple agents. Concurrency, multiple agents can run simultaneously. But the key difference is that they don't share the same space. JavaScript engines share the same address space, unlike OS processes lightweight, not full context switching overhead, limited isolation. Not as strong of OS process isolation. So, but in any case, so a process or an agent, what the fuck is an agent, bro? So an agent has its own. So an agent has its own execution environment. So an agent is something that can be. So an agent in JavaScript is something that can be run in the JavaScript engine. In the JavaScript engine. So an agent is similar as a process. Similar like a process. Exactly. So an agent is similar to a process. So an agent is similar to a process. JavaScript is sometimes. So an agent, exactly. So an agent in JavaScript is similar to a process. It's something that can be run inside of the JavaScript engine. That's an important distinction to make here. Let me clarify what engines mean in JavaScript specification versus processes. So it's an abstract concept that represents an execution environment, defines a memory model, and shared memory boundaries. Each agent has its own heap and event loop. And how do you French so you look at the event loop? So you can think of this, an agent is like a platform. So an agent in JavaScript is the platform in which the JavaScript engine can run. But the terminology is a bit different here. It's an isolator and concurrency, not the platform in itself. So JavaScript engine is what executes JavaScript, and the platform host and an agent is an isolated execution context. Think of this way: platform where, engine what, and agent is how. Isolation boundaries and concurring execution. Each agent runs on the same engine like V8 within the same platform like Chrome, but they are isolated from each other for security and concurrency reasons. So the platform plus engine is what allows JavaScript to run. Exactly. So the platform plus the engine, so where and what is going to run is what allowed to run, while agents are about organizing that execution safety. So an agent is an execution, it's a unit of execution of JavaScript. Which might be similar to so an agent is similar to a unit of execution, a thread in JavaScript. So an agent in JavaScript is similar to a unit of execution, a thread in the OS. It's because I want to, what the fuck is this, man? That's a really insightful comparison. There are important similarities and differences to understand. Both are unit of execution, which indicates that how am I going to process this? And that can run code. Both have their own execution context and state. Both can schedule by runtime system, and both represent independent flow of computations. But the key difference is that they cooperate concurrency. They yield control voluntarily. Mhm. Unlike preemptive concurrency, OS can interrupt them at any time and share memory space. Exactly, so they share memory space with proper synchronization, event-driven response to messaging input and output timers, and a single thread per agents, and managed by the JavaScript runtimes, not by the OS. JavaScript engines are more like cooperative threads or green threads. They are unit of execution that voluntarily yield control rather than being preemptive scheduled, rather than be interrupted by that. Okay, think of the OS like people talking, taking turns using a single computer. Preemptive, someone can keep you off. While JavaScript engines are like people politely passing a microphone around cooperate. Cooperate. Okay, so these agents are a unit of execution which is similar to a thread. All right. When now they can pass control, cooperate controls. They are cooperate threads. So they are similar to a unit of execution, like a thread in the OS that indicates that how this it's like how this unit of code is going to be processed. That's what an agent is. And it has its execution context tag, running context, the threads, all right. And while an agent execution thread is executing algorithm steps, the agent is the surrounding agent for those steps. The step use the surrounding agents to access the specification level execution objects held within the agents, the running execution context, the execution context stack, which is part of this stack, and the agent's records field. And this agent record fields is this, an agent signifier. Okay, but this is now talking about is the executable code and execution context. Agents, agent signifier, agent can suspend and increment modulating valuation, and so on and so forth. Agent clusters, forward progress, processing model of weak ref, clear keep objects, add to keep objects, clean up finalization registry, and can be held weekly, right? And all of this kind of stuff. Jobs and hubs operations to enqueue jobs. But again, all of this is part of the executable code and execution context. You have now environment records. You have also private, and the environment records is a specification type used to define the association of identifiers to a specific variables and functions. Based upon the lexical nesting structure of MScript code, usually an environment record is associated with some specific syntactic structure or MScript code, such as functions definition. Okay, usually an environment record is associated with some specific syntactic structure of code, such as functions declarations, block statement, or catch clause of a try statement. So when you are now declaring a function or a block, you are creating now an environment record. Each time such code is evaluated, a new environment record is created to record the identifier bindings that are created by that code. Every environment record has an outer end field, which is either null or a reference to an outer environment record, to an outer block, catch of the try statement, or functions declaration. And it's reference to the environment record that logically surrounds the inner environment record. Wait, what? The outer reference of an inner environment records is a reference to the environment record that logically surrounds the inner environment records. And outer environment records may, of course, have its own outer environment records. Exactly. So they made their own functions declaration in block scope or Scratch and so on and so forth. This is just environment records. That logically surround is that. An outer environment record may, of course, have its own outer environment record. An environment record may serve as the outer environment for multiple inner environment records. For example, if a function declaration contains two nested functions declarations, then the environment record of each of these nested functions will have their outer environment record the environment record of the current evaluation of the surrounding functions. Environment records are purely a specification mechanism and need not environment records are purely specification mechanism and need not to correspond to any specific artifact of an ECMAScript implementation. If it is impossible for an ECMAScript program to directly access or manipulate such value. But this just serves as a construct here. And this environment record, all right, that can be either is a declarative environment records, whether it's a function or a model, or per object environment records. It is used to define the effect of ECMAScript elements such as with statement, which is something that is not. And then you have the global environment record. It's used for script global declaration. It does not have an outer environment. Its outer environment is null. It may be pre-populated with identifiers binding, but here's when you this is when you populate here with all of these variables, names, aka identifier bindings, and include an association global object whose property provides some of the global environment's identifier bindings. As ECMAScript code is executed, additionally property may be added to the global object and the initial property may be modified. But this is what the environment records contains. This is the abstract methods here. Has binding, create mutable binding, create immutable bindings, initialize bindings, set mutable bindings, get binding values, delete bindings. But it's interesting because it is all about binding here. You take this identifier and binding here. Hey, this has binding, create mutable binding, creating mutable bindings, initialize bindings, set the value of an already existing but uninitialized binding in the environment record. The string value n is the text of the bound name. V is the value of the binding and it is value of the ECMAScript language type. Okay, so in this record, in this environment record, that happening is that has now these models, methods, functionality here, where it's going to now check if that has that, right? So function environment record corresponds to the invocation of a function of an ECMAScript function object and contains binding for the top level declaration within that function. It may establish a new this binding, and it also captured the state necessary to support super method invocations. But you have all of this. Okay, and object environment records and all of it, and the function environment records. This is when things started to make makes a lot of sense here. So that this value, this binding status, function objects, and the new target. The function object whose invocation caused these environment records to be created. And it has all of these properties here. this binding status lexical, initialized, or uninitialized. If the lexical value, okay, if the value is lexical, this is an arrow function and does not have a local this value. And this is when it's starting to describe is this. And the function object. And an ECMAScript function object. The global models and this value, this binding status, the function object. And then you have now the method here. Bind this value, has this binding, super bindings, and also on and so forth. Private environment record and the realm. And then you have now the realms. Before it is evaluated, all ECMAScript code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects of an ECMAScript global environment. And all ECMAScript code that is loaded within the scope of a global environment and other associated state and resource. A realm is represented in this specification as a realm record, but before it's evaluated, all ECMAScript code must be associated with a realm. And this realm records contains now the agents, intrinsic, the global object, the global env, and these values. Load models, and this realm has this set of properties. Okay. And then you have the execution context. And execution context is a specifications device that is used to track the runtime evaluation. Okay. And the component of this code of execution context is this. Okay, so things started to make quite a little bit sense. All right, jobs and host operations. So in other words, it all starts with this particular question here. So agents can be think as this unit of which is similar to this unit of execution, which is similar to the unit of execution threads in an OS that it takes the similarities, but now unlike other threads in Java or C++, this is not concurring. In other words, there's certain limitation in there. So CSS layout, MPC, not at all. I do think is this JavaScript closure, because we were talking about that. But the new chat here is this one exactly. That's when so we were evaluating is this particular go, okay, and we say, hey, when we call when the async function is called, here is what's happening. So we're gonna create a new execution context. It's creating a new realm. Okay, so a new realm is created. A new context execution is created and evaluated. The evaluation proceeds. So the evaluation begins with the return keyword. So the return keyword evaluate the expressions And this new execution context contains now that. Exactly. In this new execution context is where the lexical environment is created. All right. Mm-hmm. The realm, as well as the threat, the realm. Mm-hmm. A new execution context is created with the realm components of all execution context with the realm. If this execution context is evaluated in the code of a function object, the value of this component is function object. Mm-hmm. With a realm, with the realm that expose certain properties, okay, identify the environment records used to resolve identified reference made by code within the execution context. Mm-hmm. The lexical environments, the variable statement like var. And the private environment. Identify the private environment that hold private names created by class element in the nearest containing class. Null if there is no containing class. So with the realm, as well as the lexical environment. Lexical variable in private environment. Okay, so the evaluation of the code begins with the return keyword. The return keyword evaluates the expression with the new, I think it's new target, exactly, new target, with the new operator. Okay, and the new say, hey, I'm going to evaluate this expression, okay, which is new expression. A new expression is member expressions or new expression, okay, and this member expression can be is a primary expression, which is this, or an identifier, or a literal array. Okay, primary expressions, primary generator of functions. Okay, this identifier, reference, literal array, object, function, class expressions, generator expression, but all of these are as expressions. Okay, member expressions. Member expression this, or this, or this, with the template literal, super property, meta, a new member expression followed with the argument. Which in this case, this is the way how you pass now arguments here. Okay, so this new, which part of the member expression, and this member expression can be is either a primary expression, okay, which is this identify literal blah 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 blah. That's quite interesting. You can do something like new this type error. This is not a constructor. Oh, because he's going to look at constructors. Oof. I'll be right back. Yeah, let me now wrap this up here just to understand my piece of code here. But it's to now walk through this piece of code. I know what it's doing, but I want to actually verify and then take a look at what this code is doing according to the spec. Remember, at the end of the day, the spec is not the reality. Okay. Unfortunately for some JavaScript engines, most of them must stick to the law, but those that are not, well, they have a specific an annex in the doc. Anyway, evaluate new expression is this one, new member, evaluate new member. We got this. It's a evaluate new member. The abstract operation evaluate new takes arguments construct express and new expression parse node or a member expression parse node. An argument empty or argument parse node and returns either a normal completion containing an ECMAScript value or an abrupt completion, and it performs the following step, right? There you got it. Let be the reference of the evaluation of the constructor expression, all right? If the constructor gave you a value and the constructor expression is a new expression or a member parse node, and when they say parse node is this, the syntactic grammar. So when a string of code point is parsed to an ECMAScript, so in any case, I prefer to go into this. But the constructor here get the value. If the argument is empty, then the argument of list be new empty list. If it's not, pass the arguments, and then it's gonna call his constructor. Here is when the new keyword is telling you that. So is constructor, which I'm assuming that is going to take a look at the construct internal methods exactly. So if the argument that I'm receiving is not an object, definitely that's not that's false, right? Which is going to return you now is a type error, which is what it did when I pass this, and it say, hey, if this is not an object, which to me is quite weird, it is an object. It is an object, but this object does not have a constructor. Type error. This is not a constructor. All right. However, if I pass this and this, for example, a function, right? And this function, for some reason now, I'm going to return is this. Say function. Function contains constructor, and then now it create that. Okay. So in this case, this new word is say this. If it's not, it's going to say, hey, construct. It's going to call the abstract operation construct from the object operations, and it's going to construct now an object here. That's mind-bending stuff. The abstract operation construct takes argument f, all right, and optional arguments, argument list, and a list of ECMAScript values, and a new target, a constructor, right? And return either a normal completion containing an object or throw complete. Exactly. A normal completion containing an object or throw completion. It is used to call the construct internal method of a function object, which is exactly what it's doing. Hey, is this function contains that constructor method? You may wonder is that how do you know about exactly, because we need to pass a name. Let's say constructor function, so if I now call the constructor function here, hey, I want to know is well, what is the shape of this? Right? I want to know what is this function contains. I mean, not like this. I want to know is, I'm going to call this, right? It's a function contain constructor. But since this is the type of this, all right, and when you define now functions like this, unfortunately it doesn't tell you that, all right. Mm, not at all. So what I do want to know, so what I do want is to have access to the function object, right? That's all what I want to have access to the function object, right? To the function object. But it doesn't give me is, how can I access to that? Unless I do a function expression here and say function here. And then I try to get access to this function here. Of course, not going to return any of that. Unless I do something like this. Say return another function. Can you take a look at it? And say console log. Nested function, right? And then you say function when you call it, but it gives you that, but it doesn't. Okay. But in any case, this function, okay, as you can see here, the construct, what it's doing is calling that and now creating is exactly, and a new target, a constructor, and returns either a normal completion return containing an object or throw completion. It is used to call the construct internal method of a function object. Exactly. So is this object now contains a construct, which is by default functions allow have that. This is one of the things that I would like to explore here with functions here, with the function construction. But unfortunately here is not able to tell me that. Say what about, well, function one and function one. So if I do this, it doesn't tell me is the object in itself, doesn't return the object unless I try to do something like this. Say function one, you give me that function this. All right. Well. Okay. But is that it's going to call internal method of function object and the argument list and a new target. And these values to be passed of the corresponding argument of the internal method. If argument list is not present, a new empty list is used as its value. If the new target is not present, f is used as its value. It performed the following step when called. If new target is not present, set the new target to the function. Exactly, a constructor. If argument list is not present, set the arguments list to a new empty list. And return now the f dot construct and calls that. If new target is not present, this operation is equivalent to the new f of argument list. But at the end of the day, what this function is doing is the new keyword is creating is an object by looking at this function if it has now the construct. If it is, let me create now an object with these arguments for you, right? That's interesting. That's interesting. So, of course, that if you go and you do this kind of stuff, all right, new here, malform arrow function parameter list. Yeah, you got it. So in any case, this is quite interesting, but it doesn't support this. Why not? Malform arrow function parameter list. Malform arrow function parameter list. That's interesting. It throw this malfunction parameterless, but this is an expression at the end of the day. Um, hmm. But with function, it actually works as expected. You can call this function num, right? And it is called this. And then you say why not, and then it's going to return you now an object. All right, where this object will contains now a constructor, part of the function, and this object as it is. But this is what this new keyword is doing, is looking for the constructor method of that expression, and if it is, good. Now let me construct you an object from that. Which is kind of this thing that is happening here and so on and so forth. So, in other words, we are here. This new is going to call this the return keyword evaluate expression promise function, and since this contains a constructor method, it will create it will call the function and create an object. Okay, it will create the object, where in our case is undefined. It will create an object within this case undefined, all right, empty, and then because now how the promise work, which is by looking at the promise work, promise, I think this is part of the statement and declaration. This is more like for control. Text processing, index collection, key structure, managing memory, control abstract operations. Control abstract operations like promise objects. Exactly. A promise is an object that is used as a placeholder for the eventual result of a deferred and possibly asynchronous computation. So any promise in one of the three mutually exclusive states is fulfill, reject, and pending. Right? A promise P is fulfilled if P dot then is F and R. Will immediately enqueue a job to call the function F. Okay. This is a promise object. It's going to create now a promise object. Okay. It's going to create now a promise object. A promise is an object that is used to placeholder for the eventual result and the first computation. Okay. Any promise is one of the three mutually exclusive states: fulfill, reject, and pending. A promise P is fulfilled if P dot then will immediately enqueue a job to call the function F. And a promise P is rejected if P dot then will immediately enqueue a job to a call R. And a promise is said to be settled if it's not pending, it is either fulfilled or rejected. And a promise is resolved and it is settled or it has been locked in to match the state of another promise. Attempting to resolve or reject a resolved promise has no effect. But in other words, it will immediately enqueue a job here. A job is an abstract closure with no parameters, which is interesting that it is a closure. This concept of having this so a closure in JavaScript is when a function so when a functions so when a functions when a functions define, or when a functions declare, when a functions declare and continue to have access to variables outside of their scope, which is here, all right, even after this function is called, even after this function is called in a different scope. So in other words, what it's doing is to try to remember variables here. A job is an abstract closure, is a way to remember variables outside of a function definition that we can reference when we execute that function, with no parameters that initialize ECMAScript computation when no other ECMAScript computation is currently in progress. So jobs are scheduled for execution by ECMAScript host environments in a particular agent, in a particular unit of execution. Okay. In a particular unit of execution, whether it's the UI, whether it's the web workers. And this specification describes the host, hooks, host enqueue generic job, host enqueue finalization register cleanup job, host enqueue promise job, and host enqueue timeout job to schedule jobs. The host hook in these specifications are organizing additional constraints imposed by the scheduling of jobs. So hosts may define additional abstract operation with scheduled jobs. Such operation has set a job abstract closure and a realm or null as parameter. If the realm record is provided, this operation is scheduled to job to perform at some point at some future time in the provide realm, in the agent that owns the realm. If null is provided instead of the realm, and then you get this. At some point in time where there is no running execution, context execution, at some future point in time where there is not running context in the agent, when there is no running context, this is a stack frame, running context in the agent for which the job is a schedule and that the agent execution context stack is empty, the implementation must perform any host-defined preparation step, invoke the job abstract closure, right? And perform any host-defined cleanup state, after which the execution context stack must be empty. Okay. Only one job may be actively undergoing evaluation at any point in time in an agent. Exactly. Only one job may be actively undergoing evaluated at any point in time in an agent. Once evaluation of job start, it must run to completion before evaluation of any other job start in an agent. The abstract closure must return normal completion and implementing its own handling. So this is what is describing here in a very abstract way, is what is this is doing. It's creating now an abstract closure. It means that that functions, along with its reference, is going to be now whole somewhere, okay? And then it's going to now, at some future point in time, when there is no running context in the agent for which the job is scheduled, and the agent execution context stack is empty. This is when it's telling you when the context stack, when the stack is empty. Now the event loop, whoever is running that, is going to now perform any host defined preparation step, invoke that job abstract closures, all right, which is running that function and perform any host-defined cleanup step, after which the context execution stack must be empty. And this is what it tells you all of this. Any particular time, script or model, a script record or model record or null, is this. But this is when you create now a promise. Okay? So in this case, the promise, okay? So the return keyword evaluates the expression promise functions. Since this contains a constructor method, it will call the function, right? It will call the function here on the promise, right? And will immediately enqueue a job to the call. If a promise P is fulfilled, it will immediately enqueue to the job queue. So in other words, okay, so if the invoke, exactly, the return keyword evaluate the expression promise function, and since this contains a constructor, okay, it will call the function, which, since this is a promise, it will enqueue this, exactly. Since this is a promise, it will enqueue this in the job queue. What will enqueue? It will enqueue the function. Exactly. It will immediately enqueue a job to the call, to call the function f. Exactly. So it will immediately enqueue in the job queue the exactly, will immediately enqueue the function when there is response, when there is fulfilled. It will enqueue this job, it will enqueue this in the job queue. So it will enqueue since this is a promise, it will enqueue. So since this is a promise, it will enqueue the function, argument pass to the promise in the job queue. All right. So when the event loop, is evaluate that the call stack is empty, put the function, so put the callback here, put the callback functions on the calls on to be evaluated. Put the callback function and execute it. Since this now is invoking, since the callback function is invoking or is evaluating a set timeout, okay, the function, all right? So the function in itself, okay? So the function, so the callback function will be invoked, okay? So the callback function will be invoked, okay? So the callback function will be invoked will be invoked, exactly. So now since the callback function is evaluating a set timeout, it puts the callback function into the task queue, and when that time, and once 2 seconds has passed, the environment, the host environment, will put the, or the event loop in this case, so the event loop will put the callback function in on top of the call stack, and execute the function. Return you this is now this. Return you now is the value. New execution context created, promise construction being called, event loop mechanism with call stack checking, set timeout placing is callback in task queue, 2 second delay execution. Point 4 and point 5, the promise execution function, the callback pass to the new, runs immediately and synchronously when the promise is constructed. It doesn't get in queue in the job queue initially. It executes right away in the current execution context. And point 6, when set timeout is called inside of the executor, it schedules its callback in the task queue, also called macro task queue, not the job queue. Macro task, exactly. The job queue is for promise, resolutions, rejections. Missing step, when set timeout callbacks run after 2 seconds and calls rest, this is what puts a job in the job queue. Okay, this is what put a job. When that happened, this is what puts a job in the job queue to resolve the problem. The more accurate flow is this: a sync user call new execution context created, which contain it is realm, lexical variable in private environment. A new promise construction call immediately synchronous, okay, which create now an object, okay. Executor functions run synchronously, calling set timeout. So it calls this promise, okay. It calls this promise, all right, and this promise is executing with this instructions here, right? And inside of this set of instruction is now calling is a set timeout, where now the set timeout, the schedule is a callback in the task queue for 2 seconds later, and then promise is returned in pending state, and after 2 seconds the set timeout callback executes in calling the response. Here in the response is when the promise resolution is here. If a promise is fulfilled, then it will enqueue that. If a promise is fulfilled, then it will enqueue that. and the event loop process the job queue, resolving the promise, and the await completes. Exactly. The await completes the for of loop and can iterate over the resolve array. Exactly. So once I have that, the for of await, okay, now I can have this. This is mind bending stuff, bro. This is a mind bending stuff here. This is a mind bending stuff here. Okay. Okay. That makes a lot of sense. That makes a lot of sense. So that makes a lot of sense. Good, good, good. What is an image? Oh, is it because it's look neat? Mm. Exactly. I am well aware of this. so that'll be all for this video. Take care.